All right, this is technically section 3.4, triangle congruence proofs, what you've all been waiting for. If you've ever had an older sibling or a friend that's been through geometry already, they all probably have told you how much they hate proofs. And this is kind of your first introduction to them. Now, I don't think they're so bad, but we'll see. You have to use a lot of vocabulary and some former unit knowledge in order to complete these. So first of all, I don't know why the given information isn't there, but let's take a look at our diagram. Let's talk about some symbols so we can identify our given information. So first of all, do you see these two arrows here? Those are telling you that the lines are parallel. So the first piece of given information is that BI, I'm actually going to use black, BI is parallel. So here's our parallel symbol. So if you see those two bars up and down vertically like that, that means parallel to EK. Okay, so that's the first thing. The second thing is that, so put a comma, BI is congruent to EK from those single bar markings right there. So that's everything that you are given. And normally, if you look at the second example, it'll actually give you the information, but it's good to identify it from the diagram. So now we're going to start our proof. So our first statement is everything we've been given. So we'll just write it down here. BI is parallel to EK and BI is congruent to EK. And our reasoning is always going to be that it was given. In order to do a proof, you have to be given some information. We're not just going to give you a diagram, tell you to prove something, and then say good luck. I'm not going to give you anything to start with. That's not fair. It's not even possible. Okay? So you always start with your given. Now we need to look at the diagram. We have to use some prior knowledge, some prior terminology in order to identify more parts, because our goal in step number 4 is to say that triangle BIE is congruent to triangle KEI. That's our goal, and then hopefully we get enough information to give a legitimate reason as to why. So all this is an argument. It's you sitting across from your friend maybe, and you're saying, hey, these two triangles are congruent, and then you're trying to figure out why. You're arguing as to why they are congruent. Here's the hard part. You have to use some Unit 2 knowledge, maybe even some Unit 1 vocabulary. So let's take a look. The first thing, and probably the hardest thing, I think anyway, to see is that if we have two parallel lines, I'm going to highlight these. Two parallel lines cut by a transversal. We know that this angle here and that angle there are congruent. So I'm going to say that. That's going to be my second statement. I'm going to say that angle, I'm going to start with BIE is congruent to angle KEI. So the hard part to me is coming up with the statement. Hopefully, even though it's maybe not the easiest to see, but hopefully you can look at the diagram, what I've highlighted, what I've shown, and you can tell me why that's the case. So the reasoning would be alternate. I'm going to shorten up some of these words here. Interior angles are congruent. And that's what we talked about last unit. If we have two parallel lines and a transversal, alternate interior angles are congruent. So that's the first piece of information. So I'm going to leave those marked, because if you remember from the last video, at the end we talked about shortcuts to proving triangles are congruent. We're going to use those. We're never, or very rarely, are we ever going to go through and list all 6 angles and all 6 sides. We can use the shortcut, so why not? Okay, step number 3 here. So it's maybe good if you just have these available just off to the side somewhere for you. So our goal is to either get all 3 sides, side, angles, angle side, angle, side, angle. And we're not worried about hypotenuse, leg right now because it's not a right triangle. So maybe label what we have. We have a side, we have an angle, we have a side, we have an angle. So right now, that would eliminate this one. We've already eliminated this one. We have a side, an angle, so we either need another side for this one, or we need another angle for either one of these. Let me get rid of those. Let's jump back over. Now, another piece of advice for you, and sometimes it's hard to see, but anytime the triangles share a side like that, we can say that EI is congruent to IE, or whatever. You can write it the same way. And the reasoning is that reflexive property we talked about last unit, or not last unit, last week. Okay, so we can say that the side is congruent to itself. That's always going to be the case, whether or not you can actually use it. I can't help you determine that, but you can always say when they share a side, you can always say that it's congruent because of the reflexive property. So now let's take a look. So starting with my top triangle, I have a side, I have an angle, now I have another side. So I have two sides with an angle in between, side, angle, side. On the bottom triangle, I also have side, angle, side. So I'm telling you that they're congruent. You have now given me enough information to say that those two triangles are congruent by side, angle, side. This one right here, we have two sides with an angle in between. So keep this little thing handy. Will you have to know that by the test? Yeah, you'll have to know what they look like. Spend a little time outside of class looking at those. Now we have one more, and this is going to use some vocabulary from Unit 1. So, number 1, always just write your given information. So, BD bisects triangle A, or angle ABC, and BD also bisects angle ADC. And your reasoning is always just going to be that it was given. You always have to start with given information. So the first step in these proofs should be pretty easy. The last step, 1, 2, 3, 4, 5. The last proof or last step, triangle ABD is congruent to triangle CBD. And then hopefully we'll get one of these 5 reasons for that. All right, so in order to do this one, you have to know what that word bisect means. So if I have a ray or a line segment in this case, bisecting an angle, ABC, what it means is that these two angles are congruent. Right? That's what it means. So that's your step number 2. We can say that angle, there we go. So that would be angle ABD, right? This angle here is congruent to angle CBD. Right? And the reasoning is that's just the definition of a bisector. That's what it does, so that's all we're going to write. Definition of, I'm going to put angle bisector. That's just what an angle bisector does, is it tells you it splits two angles in half so that they're congruent. Okay, similarly, BD also bisects angle ADC, so that means that this angle here and that angle there are congruent because that's what a bisector does. That's just the definition of a bisector. So step number 3 is going to look very similar, just a different angle. So we're going to say angle ADB. Oh, there we go. Is congruent to angle, angle CDB. Okay, and again, that's just the definition of an angle bisector. That's exactly what it's telling you. So that's the hard part to me about proofs, is that you see a word bisector, you have to know what it means. And then you're probably going to use that somewhere in your proof. In this case, we did. Now, the last thing, I just talked about it in the last proof, but they share a side. They share a side, BD. So I can put this marking right here, and I can say BD is congruent to, oops, I don't want to write an angle, DB, or wherever you want to write it. And that is because of the reflexive property. That's going to be a huge one. Anytime they share a side, you're probably going to use the reflexive property. So we have all of our information. Now you have to decide which of these 5 am I going to use. Because I'm telling you they're congruent. You've used the proper steps to get there. Now you have to decide, okay, which of these 5 did I get all the information for? So if you take a look, on the left triangle, I have an angle, I have a side, and I have a second angle. On the right side, I have an angle, a side, and a second angle. So I'm going to put angle, side, angle, and then let's just make sure that that works. Is that one of the 5 options? Boom. There it is. 2 angles with a side in between. And that is just basic proofs. You know, it's one of those things, it's just going to take time. It's going to take practice. It's going to take a lot of prior vocabulary knowledge. But we're going to get through it. We will. We'll practice this a lot more in class, but that is it.